Welcome everyone. Today we are going to start lecture 2 on continuity, and we'll discuss today some important questions on continuity, and these questions will be very simple to solve, but you should really solve like this question, because these are the questions will help you to clear your basics, and slowly you can go for questions having more difficulty level. So to start today's lecture with a very simple question. A function is given that fx equal to x plus 2 for x less than 1 equal to 0, x equal to 1 and x minus 3, x is greater than 1. The question is, discuss the continuity of the function. So we need to see whether the function is continuous or is there any point of discontinuity. Okay, we'll be solving these questions for these cases, like we'll take solve this for x less than 1 and x greater than 1, and for x is equal to 1. So let us try these cases one by one. So it will be case 1, okay, case 1, okay, let c less than 1. Okay, just start with the case. We know that the nomen of this function is real numbers. First we'll try to see the continuity for all the real numbers which is less than 1. Okay, so we can just find a limit like this. Limit x tends to c f of x, and here we are assuming c less than 1. So limit x approaches to c. So since x approaches to c, and we have considered that c is less than 1, so fx can be replaced by this function x plus 2. X plus 2. So this gives us c plus 2, and c plus 2 is nothing but f, okay, c. Why f is c plus 2? Because c is less than 1. If c is less than 1, f of c will be c plus 2. So with the help of these simple steps, we can show that this particular function is continuous for all the value which is less than 1. Okay, so similarly you can try for the case 2, that is a continuity, or can check the continuity for c greater than 1. Let us check the continuity for second case, that is for c greater than 1. Okay, so if we take, okay, this will be case 2. Okay, case 2, let c is greater than 1. Okay, similarly we will just find out the limits. Limit x approaches to c f of x. Right here, c, we have considered c is greater than 1. So if you are approaching c from either of the directions, then fx value is always is equal to x minus 3, because fx equal to x minus 3 for x is greater than 1. So limit x approaches to c, so fx is x minus 3. Done. So these are the questions are very simple. Okay, so quickly you can find the steps. This is equal to c minus 3. Okay, c minus 3, and the c minus 3 is equal to the functional value at c, fc. Okay, since c is greater than 1, so f of c will be c minus 3. So with the help of the similar steps, we have seen that the function is also continuous for c greater than 1. So these are the steps are very simple. Okay, and now third steps, that is case 3. So we need to check the continuity of the function at x equal to 1. Let's see what happened. Okay, whether the function becomes continuous at x equal to 1 or not. Okay, this will be case 3. Okay, let c equal to 1. So now since you are assuming c equal to 1, so we need to calculate left-hand limit and right-hand limit separately. So limit, okay, x approaches to 1 minus. X approaches to 1 minus, because in place of c we have taken 1. So x approaches to 1 minus fx. I know you can really understand that why for c equal to 1 you have to consider left hand limit and right hand limit, because the moment you will be approaching 1 from the left hand side, so x will be less than 1. For that the function will be x plus 2, and if you approach c from the other direction, from the right hand side, then the value of x will be slightly greater than 1. So fx value will be x minus 3. So this fx will be different for left hand limit and right hand limit. So you need to solve this particular case c is equal to 1 by taking left hand limit and right hand limit. So limit x approaches to 1 minus fx, limit x tends to 1 minus. So 1 minus fx value will be x plus 2. So if you take the limit, so it will be 3. Okay. If you take the limit, if you put the limit, 1 plus 2 is 3. So let us calculate the right hand limit. So let's see what is the right hand limit. Right hand limit, okay, limit x approaches to 1 plus f of x is equal to limit x tends to 1 plus. X tends to 1 plus means you are approaching 1 from right hand side, so x will be greater than 1. So fx can be replaced by x minus 3. So in case if you substitute x equal to 1 is equal to minus 2. So what I have seen that here left hand limit is not equal to right hand limit when you take c is equal to 1. So what we have understood that for these functions the only point of discontinuity is x is equal to 1. So 1 is a point of discontinuity and rest of the point the function is continuous. So it can also be seen with the help of a graph. So just if you draw the graph, that is fx equal to x plus 2 and fx equal to x minus 2 lines. This is a simple graph. Okay, you can just draw for y is equal to that fx equal to 1. So you can just write y equal to x plus 2. This one you can just write y equal to x plus 2 and fx is y equal to x minus 2. So if you draw this two graphs, remember this, the moment you draw y equal to x plus 2, this, I'm talking about this line. So here domain is x is less than 1. So that means for x less than 1, the graph will be like that. And if you draw this graph, y equal to x minus 2, so x is greater than, so your domain will be x greater than 1. So you can, okay, we have seen in the graph is that this graph, we can just keep drawing the graph, but the moment, okay, we approach to 1, okay, 1, so there will be a break. Right? There will be discontinuity at x equal to 1. So again if you process, so the graph can be drawn continuously. So therefore this also can be drawn for x less than 1. The graph can be drawn continuously, but there will be a break at x equal to 1. That means you need to lift your hand. Okay, you need to lift your hand and then again you need to draw. Okay, so that therefore the same questions can also be understood clearly from the graph also. So one point of discontinuity in this question is at x equal to 1. Okay, so let's move to the another simple question. Okay, this is actually the property of the greatest integer function that we are going to discuss some property based on these questions. Find all the points of discontinuity of greatest integer function. So this is the questions. We need to find the point of discontinuity. Okay, so how can you solve these questions? Okay, we'll just divide this answers into two parts. Like we'll be trying to find a continuity for a value which will be an integer, and similarly we'll try to find a continuity of the functions for a value which is not an integer. Okay, so just solve with case 1 and case 2. Case 1, let C be a number which is not an integer. So try to find a continuity for non-integral numbers. Okay, let C be a number which is not an integer. Okay, so just can find out with that limit. Okay, x approaches to C f of x, limit x approaches to C. Remember that C is not an integer, it's a non-integral number. Okay, fx can be replaced by this. So therefore this will be, if you take the limit, this will be the greatest integer value function C, and that is definitely will be equal to f of C. The reason is that since C is not an integral number, okay, not an integer, right? So therefore limit x approaches to C, the greatest integer function will be obviously that greatest integer value function C. So that is equal to f of C. For example, if you take say x is equal to Okay, x is equal to 5.5. If you take x equal to 5.5, so if you approach x equal to 5.5 from the left hand side or from the right hand side, for both the cases, so 5.5, okay, if you approach 5.5 from the left hand side, okay, the value will be slightly less than 5.5, so greatest integer value function will be 5. And if you are approaching 5.5 from the right hand side, okay, if you approach 5.5 from the right hand side, then the value will be slightly greater than 5.5, so that also give you 5. Therefore, limit x approaches c. Most important is you need to see, you need to like observe this particular value. What is this? This is a non-integral numbers. Therefore, limit x approaches to c, that greatest integer value function c is equal to box c, and that is equal to f of c. So we have understood that the limit x approaches c fx, that means both left hand and limit, right hand limits are included there. Okay, so here since c is not an integer, you don't need to calculate left hand limit and right hand limit separately, because both will give us same result. Okay, so that is equal to the functional value. Hence, with the help of these steps, you can understand that function, that is fx equal to greatest integer value function x, will be continuous if c is not an integer. Okay, let us see, let us go for the next case, that is, okay, the other case, right? We'll take case 2, let c be an integer. Okay, right? In that case, c, remember this, let c be an integer. Then limit x approaches to, will approach this integer from the left hand side, fx. Limit x approaches to c, then fx will be replaced by this. Now remember this c is an integer. So if you approach c from the left hand side, okay, this value x will be slightly less than the integer, right? Say for example, if you take c equal to 5, and if you approach 5 from this left hand side, the value can be 4.99. Now what will be the greatest integer value function? 4.99. 4.99 will be 4. Then how this 4 can be written in terms of 5? That 4 can be written in terms of 5 as what? 5 minus 1. So therefore, this x approaches to c minus greatest integer value function x will be c minus 1. Okay? Right. Similarly, if you try for the right hand limit, x approaches to c plus f of x. Okay? Limit x approaches to c plus, okay, box x equal to. Now let's see that c is an okay, integer here. Like x approaches to c, that means you are approaching c from the right hand side, so value of x will be slightly greater than c. So here we are considering c is equal to 5. So if you are approaching 5 from the right hand side, the value of x will be slightly greater than 5, could be 5.11, so that always will give you 5. So you have taken the value c is equal to 5, and the greatest integer value function 5.11 or 5.01 also give you 5. But therefore, this will be is equal to c. Okay, limit access to c plus greatest integer value function x will be actually c. Why? Again, I'll just repeat this, because you are approaching c. C is an integer, remember that. You can take an example. C is an integer, you are approaching c from the right hand side. So if c is an integer, so this you are approaching c from the right hand side, so naturally the value of x will be slightly greater than the integer. So if you take c equal to 5 and you are approaching 5 from the right hand side, so value of x can be 5.001. Okay, now important is that what will be the greatest integer value function of 5.001? That is equal to 5. So there is no difference between the greatest integer value function of 5.001 and the value of c, that is c equal to 5. So therefore, this can be directly written as c. Alright? Yes. So what you have seen, right? Here you have seen that the moment you are approaching c, okay, and while considering c is an integer, okay, so you got the left hand limit, okay, so when c approaches to okay, from the left hand side, the left hand limit is equal to c minus 1 and right hand limit is equal to c. Okay, since left hand limit and right hand limit are unequal, right, Therefore, this function, that is fx equal to box x, or the greatest integer value function x, is not continuous for integral values. That means the point of discontinuity will be when c will be an integer. Okay. Now we have discussed that if c is not an integer, okay, c is not an integer, then the function, this function fx is equal to that gi of x is a continuous function. But the moment if we consider c is an integer, then this left hand limit becomes unequal with right hand limit. That means we get a point of discontinuity. Okay, so we can just understand this question with the help of the graph of this. That what you have, you have learned in class 11, or for a class 11 student, if you are watching this video, then let's try to understand the graph. Okay, and the graph can be drawn. So if you take x lies between 0 to 1, that is greater than equal to 0 and less than 1, then what will be the, if you take any value between 0 to 1, then greatest integer value function always will be equal to 0. Okay, therefore this graph can be drawn here from this point to this, but remember that here 1 is excluded, right? Similarly, if you draw the graph between 1 to 2, have you seen 1 to 2? Here gf of x will be equal to 1, right? So this is 1, this is the graph, and here x, it starts with 1, but 2 is excluded, so 2 is not there. So this circle, okay, this circle, from this circle we understand that this 2 is not a part of that particular graph. So from the graph it's very clear that at x equal to 1, okay, there is a break. That means you need to jump from this graph to this. Similarly at 2 there is a break. If you come down here, okay, at 0 there is a break. Okay, similarly at -1 there is a break. So at all integral points like -1, -2, 0, 1, 2, 3, all integral points, the function is discontinuous. Okay. Otherwise, if you check the points between say 1 to 2, have you seen this graph can be drawn continuously? If you see like from 2 to 3, the graph can be drawn continuously. Okay. So these questions we can understand clearly from the graph also. This is a very important graph. I just request you to draw the graph, okay, and see the continuity. In most of the cases, it becomes very clear if we just try to draw the graph. Okay, and we'll just move to the theorem of continuity, that is algebra of continuous functions. A very important theorem I'm going to learn. Okay, theorem. Let f and g be two real functions continuous at real number c. Okay, it's given. What is given? That f and g be two real functions, and both f and g are continuous at c. Then f plus g is continuous at c, and f minus g is continuous at c, fg is continuous at c, and f by g is also continuous at c. So these are very important and useful outcome, because in most of the cases we can directly apply this theorem. Okay, just try to prove this. Okay, one or two outcomes just we are going to prove this, because if we just prove one, it's enough, like, because all the proofs are similar. Okay, we'll just try for a proof. Okay, a proof. What we are going to prove? We're just going to prove this. F plus g is continuous at x equal to c. We have to prove this. F plus g is continuous at c. What is given? What is given in this theorem? It's given that f and g both are separately continuous at x equal to c. So let's start with this. So limit x approaches to c, f plus g x. We'll just start with this. Okay, so what's the next steps? Limit x approaches to c. So we'll just use this definition, fx plus gx. Okay, fx plus gx. Then we'll be using the theorem of limits. Okay, there was a theorem similarly, this theorem, algebra of continuity. There is also one concept, that algebra of limits, and there we have a theorem, that is theorem on limits. So I'm going to use this. So limit x approaches to c, fx and gx, and remember this, f and here it's given. Okay, f and g both are continuous function. It's given that. So we are going to use that, right? So with the help of the algebra of limits, you can just write limit x approaches to c, fx plus limit x approaches to c, gx. Okay, so we have seen that here this is the application of limits. And now limit, which is we'll be using the definition of continuity. Fx is continuous, therefore limit x approaches to c, fx will be equal to f of c. This is very simple. This is the definition 1. What we have explained in lecture 1, the limit x approaches to c, fx equal to f of c. Okay, and similarly, this is gc. Then we'll be using the definition of function, that is f plus g c. So now please compare these steps. Okay, you compare these steps with this. You compare these steps. Okay, how did you start? Limit x approaches to c, f plus gx. That you have proved like this is equal to f plus gc. So which is exactly equal with the definition of continuity. So if we know that if fx is continuous at say x equal to c, then according to the definition it should be x approaches to c, f of x should be equal to f of c. What is the meaning? The meaning of this particular expression is that limit x approaches to c, that means if you approach c from either of the directions, okay, that means left hand limit and right hand limit both are equal to the functional value. So here also we have proved that limit x approaches to c, f plus gx, okay, is equal to f plus gc. So this is a functional value. This is exactly equal as f of c. So with the help of this, you can say therefore f plus g is continuous at x is equal to c. So things like okay, the other proof also exactly similar to this. Okay, just you can prove the rest by yourself. Okay, I'll just move to some other questions. Okay. But this is also very important, that why I'm selecting these questions like this. Many questions are there. So the moment you can just go through this. Okay, otherwise you know that cos, sine, these functions are always continuous functions. But in case it's given to prove, like okay, discuss the continuity of cosine functions, right? In that case, you will have to show the steps. Okay, why that cosine function is continuous. Okay. If it is for 1 mark, sometimes you can show with the help of the graph also, and but if it carries more marks, then you can just consider the steps. Okay, let fx equal to cos x. Okay, and we know that what's the domain of cos function? The domain of cos function is R. Okay, we'll just consider any real number. Let C be any real number. Okay, so C is arbitrarily chosen any real number. We're trying to see the continuity at x equal to c. Okay, limit x approaches to c, f of x, right? So limit x approaches to c. Okay, fx means cos x. Then what I'm going to do is, let us assume that x equal to c plus h. Okay, we'll just substitute x equal to c plus h. Now, if x approaches to c, because this is x approaches to c. So let's see, like, because we are introducing a new term h, like we need to know that, okay, what will be the limit of h? If x approaches to c, then h will be approaches to 0. Okay, so h will be approaches to 0. So limit h approaches to 0. I think, okay, I just can repeat this. X you are assuming as c plus h. Now this x is, if it is very, very close to c, then h obviously will be approaches to 0. Okay, h will be approaches to 0, and cos. Then we'll be replacing the value of x. What is the value of x? X is c plus h. Done. Okay, next, we are going to use that cos a plus b formula. Okay, cos a plus b formula, limit h approaches to 0, cos a plus b formula, cos c, cos h, minus sin c, sin h, cos a, cos b, minus sin a, sin b. Okay, all the steps, you have seen that all the steps are very, very simple. Okay, now what is the next step to be followed? Okay, we'll be using the algebra of limits. So limit is a procedure, it's a binomial. We can take limit on this function minus limit on this function. So if you take limit on this function, cos is constant. So we need to take limit on only cos h. H separates to 0, cos h. Done? Minus. Now again sin c and sin h. Okay, sin c is constant. So you can take the limit on sin h. Limit h separates to 0, sin h. Okay, from this we have two important concept that already these are the concept you have learned. Okay, and see limit h separates to 0, what is the value of cos h? And limit h separates to 0, what is the value of sin h? Okay, we know that limit h separates to 0, cos h is always equal to 1, and limit h approaches to 0, sin h is always equal to 0. These are very common properties, and you can check this one with the help of the graph of that cosine function and sine functions. Okay, the limit h separates to 0, cos h always is 1, the limit h separates to 0, sin h is always equal to 0. So therefore, okay, we'll just go to the particular yes, okay, right. So I'll just write the steps here. Okay, what's the next steps? So this is cos c into, so h separates to 0, cos h is 1, then minus h separates to 0, sin h will be 0, so this part will become 0, so it's 0. So this is equal to cos c. So how did it start? Started with this. Have you seen that? Limit x tends to c, f of x. So that is always equal to f of c. What is f of c? F of c is equal to cos c. So cos c you can replace as f of c is equal to cos c. So cos c can be replaced as by f of c. So finally, what we have seen that therefore we can just write the steps. Therefore, limit x approaches to c. Okay, cos x equal to cos c, which is equal to f of c. So limit x approaches to c, cos x is equal to f of c. That means let them limit, right limit, and functional value all are equal. Therefore, this cosine function cos x is a continuous function. This is a mathematical mathematical proof for a function cosine is continuous. Similarly, you can try for the other functions. Okay, we'll be solving another very important questions. It's okay, and this question is taken for a reason. Okay, how easily with the help of the composition function, how this function can also be solved. Okay, we'll try to solve this one. In case you can solve this one with the help of other method, but just okay, it's given in the NCERT. Let's try to prove with the help of the composition functions. Okay, so how to discuss this question. Find all the points of discontinuity of f defined by this. So let us check that whether is there any point of discontinuity. Okay, so what I'm going to do is, so this is a known function for us, that is a mode function. So let's focus on that. Okay, let hx equal to mod x, right? Now, okay, we'll just discuss about that. First, this function, that is mod x plus 1. Okay, though we know that what is the property of mod x plus 1. But the moment the question asks like that find all the points of discontinuity, so we'll have to show the steps. Okay, clearly, we'll just assume that gx equal to x plus 1. So remember this, what the way the functions are being taken. These are all known functions. One is a mode function, this is mod x. Then we have already learned that mod x is always continuous. Then gx, that is x plus 1, is a polynomial function which is always continuous. Okay, now we just try to write mod x plus 1. Okay, we'll try to write mod x plus 1 in the composition of these two functions. Okay, let's start with this. So mod x plus 1, right? Mod x plus 1. So if it is mod x equal to 8x, mod x plus 1 will be 8x plus 1. So this is the property of hx. Hx is mod x. So hx plus 1 is mod x plus 1. Now, it's, what is the value of x plus 1? X plus 1 actually is zx, right? Just substitute the value of x plus 1. X plus 1 is zx. So, x plus 1 is zx. Therefore, this can be written as h naught dx, right? So, the moment you write mod x plus 1 is h naught dx, your problem is solved. That means this particular function is possible to write as a composition of two functions, that is h and g. But most important, what is h and g? H is a mode function, right? Mod x, which is continuous. And what is gx? Gx is a polynomial function. This is also continuous. That means this is a composition of two continuous functions. Therefore, mod x plus 1 is a continuous. Okay. So see the question, function. This is mod x is a continuous function, and mod x plus 1 also now we have proved it is continuous. In fact, we know like mod x plus 1 is continuous function, right? It's actually a continuous function. This is also continuous function, and difference of two continuous function is always continuous. But anyway, since this one already we have done that hx is equal to mod x, okay, we can accept, right, that this is a continuous function. And since it was asking us to find all the points of discontinuity, let's try to explore this x plus 1. So mod x plus 1 we are writing in the form of composition functions, that is h naught dx. In case this question comes, okay, for 1 mark, that show that this particular function fx is continuous. So you can definitely use the concept of algebra of continuity, since mod x is a continuous function. Both this function mod x and mod x plus 1 continuous function, or difference of continuous function is continuous. So we're just trying to prove, in case this type of questions are given and they expect us to explain why mod x plus 1 is a continuous function. In that case, you can consider these steps. Okay, mod x plus 1 is h naught dx. So therefore, mod x plus 1 is continuous function. Hence, fx is a continuous function. That means, okay, there is no point of discontinuity for fx equal to mod x plus 1. So this is one way you can just try these questions to solve. Okay, and thank you so much, and we'll be coming with another important video on continuity, where, okay, questions from that is question from NCERT, okay, question from the references will be there, okay, so that it will help you to solve question easy, difficult, all, okay. And thank you for watching my video. Thank you.